Okay, so far we have been talking about atoms and elements, and inside the atom, which are the particles that are there. And we are going to see now how the electrons are arranged around the nucleus of the atom. So this is the part 3. The electrons are going to be located in the around the atom in zones of energy that we call also shells or levels of energy. We are going to use the model, the Bohr's model, which is the planetary model, even though it's not accurate for many things, but for this level it's going to be easier for us to remember that. So the first shell of electrons can hold up to 2 electrons, the second one up to 8, the third one up to 18. So if lithium has 3 electrons, of course, the first thing is going to be filled out the first level before filling out the second level. We always fill out the inner levels before going outside. So it's going to have 2 electrons in the first level or first shell and 1 electron in the second shell. Following the examples that we had before about lithium and fluorine, in the case of fluorine, the atomic number is 9. That means that it has 9 protons in the nucleus, and so it's going to have 9 electrons. 2 are going to be in the first level. So we can write down the electronic configuration as 2, and then it has 1, 2, 3, 4, 5, 6, and 7 in the second one. The addition of these 2 electrons levels has to be the same as the number of protons that we have in the nucleus. Now, we are going to talk about the group number. We said that the group number, or the group where the element is located, is the column, and the column here is going to be given by the valency electrons. The valency electrons are the electrons in the last level. So we are going to see which are the electrons that it has. In this case, we have sodium. Sodium has 11 electrons, so it's going to have 2 in the first level, 8 in the second level, and 1 in the third level. If you see, the sodium is located in the period 3 because it has 3 layers of electrons, and the amount of electrons in the last level, in this case only 1, is going to be the group number. So this means that it has 1 electron in the last level. And how many layers it has? 1, 2, and 3, and that's why we have 1, 2, and 3 layers. In the case of the calcium has 20 electrons. Where the calcium is located? Here. So I can see that it has 1 layer with 2 electrons. The second layers, if you don't remember, is 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 2 electrons in the first level, 8 electrons in the second level, 1, 2, 3, 4, 5, 6, 7, and 8 electrons in the third level. And in the fourth level is going to have 2 again. How do I know that? Because of the position in the periodic table again. Which is the group number? Well, the calcium is located in the second column, so that is group equals 2. So it's group 2. In the case of the aluminum, it's going to be 2 electrons in the first level, 8 in the second level, and 1, 2, and 3 in the third level. So that's why it's 2, 8, and 3. This electronic configuration is a very simple one. We are going to see that for the honors classes and the district examination, you need to know a second way of doing the electronic configuration. This is the basic one, showing only the shells. The period number. The period number is the row where is located the element. So in this case, the sodium is going to be in period 1, 2, 3. This is in period 3, and you can see that looking at the electronic configuration, it has 2, 8, and 1. That means that it has 2 electrons in the first level, 8 in the second level, 1, 2, 3, 4, 5, 6, 7, and 8. If you don't remember, just count. And in the third level is going to be only 1. Don't don't worry about this part because we are going to talk about that later. Okay, so far we are going to talk about the first 20 elements, so calcium is going to be the bigger one that we are going to talk about. In the calcium, we have 2 electrons in the first level. Then we are going to have 8 electrons in the second level. Then 8 electrons in the next level, and 2 electrons in the outer shell. The outer shell is going to have only 2 electrons. If they ask you to draw the element, it's going to be the nucleus, that you don't have to put all the things here, just the nucleus. Then it's going to be 2 electrons in the first level. Then it's going to have 8 in the second level. 1, 2, 3, 4, 5, 6, 7, and 8. Then it's going to have a third level. Then it's going to have the third level with 1, 2, 3, 4, 5, 6, 7, and 8. And in the last level, we are going to have only 2 electrons. Okay, those are 2, 8, 8, and 2. This is going to be the first layer or shell, the second layer, the third layer, and the fourth layer. And in the case of the aluminum, again, it has 1, 2, and 3, so it belongs in period 3. And you can see that the aluminum is in period 1, 2, and 3. It belongs in this period. It has 2 electrons in the first level, 8 electrons in the second level, and 3 electrons in the last one. If you look at the electronic configuration and the group number for the first 20 elements here, they are the ones that are in yellow here in the periodic table, and you are going to see that this area here is not represented. That should be in the middle here. So we have the amount of electrons in each level, which are with the electronic configuration at the bottom here. You can see that in this level, for example, all the elements have 1 and 2 layers, 1, 2 layers, 1, 2 layers, 1 and 2 layers. So all of these one have the nucleus of the atom, and then are going to have 1 and 2 layers. And the amount of electrons are going to be determined by the group number. So in group 1, it has 1. In group 2, it has 2. In group 3, it has 1, 2, and 3. So the period number is the number of layers or number of shells. And the group number is the number of electrons in the last level. Okay? So each column, there are the same amount of outer shells, in the outer shell electrons. The outer shell electrons are the electrons in the last level. 1, 2, and 3 times 2 is 6, plus 1, 7. That is why this is called group 7. And this one also, 2, 4, 6, and 1, 7. All the elements in group 8 have 8 electrons in the last level. Be super careful because helium has only 2, because it has only 1 layer, and 1 layer, the first layer, can hold up to 2 electrons. It cannot hold more than that. What is the importance of this? It's important because the amount of electrons in the last level are going to give the chemical properties. For example, chlorine and fluorine are poisonous, and both of them have 7 electrons in the last level, fluorine and chlorine. Bromine is also poisonous, and iodine is also poisonous. That's why we use them as disinfectants, for example. And the elements in the last level, in the last column, I'm sorry, are all noble gases, because they are very stable and they don't combine with any other element. That's why they call noble gases or inert gases too. Now, because they don't share or gain or lose electrons, they are also going to be called group 0, because they don't put those electrons on the table for bonding. And we are going to see bonding in the next chapter, chapter 4. Okay, when we want to know if the element is going to lose or gain electrons, that depends on the size of the atom. It's one of the things that is going to determine if the element gains electrons or loses electrons. So all the elements that are in this area, you can see that they are very small, comparing them with the metals that we have on the left of the periodic table. These elements are going to lose electrons. These elements are going to gain electrons. Most of the time they lose these electrons in the last level to get the configuration of the noble gas before. For example, calcium is going to lose these 2 electrons that it has in the last level to get the configuration of argon here. Or magnesium is going to lose these 2 electrons to get the configuration of neon here. I'm going to erase before I begin. I can continue explaining that. Now, in the case of fluorine, for example, fluorine has 7 electrons and is going to gain only 1 to get the configuration of neon. Oxygen is going to gain 2. That's why the oxygen forms the oxygen 2 negative, or the ion oxide. And nitrogen is going to gain 3. Chlorine is going to get 1 electron extra to get the configuration of argon, and so on. In general, the radius of the atom is going to increase when we go down in the periodic table. Why is that? Because when we get from the lithium to sodium, for example, we are increasing the amount of layers. So this one has 2 layers, this one has 3 layers, this one has 4 layers. How do I know that? Because of these numbers here. Okay, the number of the period is going to tell me how many layers of electrons they have. So when we go from top to bottom in the periodic table, we are going to get from smaller to bigger. Now, what happens when we go from left to right in the periodic table? We are going to have the same amount of layers of electrons, but the charge, the amount of protons in the nucleus, are going to increase, because sodium has 11 protons, magnesium has 12, aluminum has 13. So the same layers are going to be attracted by more more protons in the nucleus. And that means that the attraction for those layers, the outer layers, are going to be bigger, so the elements are going to be smaller and smaller. So when you go from top to bottom, you are going to have an increase. When you go from left to right, you are going to decrease. Okay, so that's why I think that this periodic table with the actual sizes of the atoms is going to be more sufficient than my explanation with paper and pencil. Now, when we talk about the history of the atom, we talk about the Bohr's model. And in the Bohr's model, in the sodium, for example, we have the nucleus of the atom, and then we have 1 layer, 2 layers, and 3 layers. Okay, now if I have 1 electron here, and the electron, I give energy to the electron is going to jump up, absorbing that energy, and they are going to absorb that energy in the form of light. And we are going to see that in the next chapter, which is going to be waves. When the electron is in the position that it has to be, then it's going to be what we call ground state. Ground state is like the normal state for the electron. If I give energy to that electron is going to jump and is going to absorb that energy. So I give the energy, the electron is going to jump. I'm going to use another color because you are going to get confused. So let's say that the electron jumps here, absorbing energy. That is going to be what we call an excited state. but the electron doesn't want to be in the excited state, so it's going to return as soon as possible, and returning as soon as possible is going to emit energy. How much energy is going to emit? Depending on which is the jump. These are the representation of the levels of the electrons. Level 1, this is, let's say, the nucleus, and then we have level 1, level 2, level 3, level 4, level 5. So as we go up, we are going to have the layers uh, closer and closer, and that means that these jumps from any of these layers towards the first level of electrons, like this one here that I did in the graph, are going to release energy in the sun of the ultraviolet wavelengths. If they jump to the second layer, we are going to see those colors. Why is that? Because that is visible wavelength. That is the part of the visible spectra that we can actually see. And if they jump to the third level instead of the second level, the amount of energy that is released is going to be so small that it's going to be in infrared wavelengths. Why is this important? Well, it happens to be that the levels of electrons are not going to be only levels. They are made of also sublevels, and that is what we are going to see in the next slide. Okay, you can see here that I have the first layer, okay, I have the second layer, and I have the third layer. It happens to be that the first level of electrons is made on only not of only levels, but also sublevels. They are divided. And how they are divided? They are divided in sublevels. For example, the first level has the first level, level 1, has one sublevels. Level 2 has two sublevels. Level 3 has three sublevels, and so on. The number of levels, the number of sublevels, I'm sorry, they are going to be increasing and increasing and increasing when I go up. And the problem is that they are getting closer and closer. You saw that in the prior slide. So what happens is this: when I see the layer number 1 is going to have only one sublevel. Layer number 2 is going to have two sublevels. But as I go up in the sublevels, they are getting closer and closer, and some of the sublevels are going to be overlapping. It's like they are going to be like getting mixed. Okay, so it's going to be kind of a mess. So luckily we have the periodic table and we can figure this out. Do not freak out. I know that many of you are not understanding what I'm saying right now. The only thing that you need to remember is that the levels are made of what we call sublevels. And look at the letters that I have here. These are the names of the sublevels, and the sublevels are S, S and P, S, P and D, S, P, D and F. And you're going to say, what is this happen to be with the electronic configuration? Well, because there are levels within the levels, or what we call sublevels within the levels. We need to figure out how the electronic configuration is going to be for the elements when we have those sublevels into consideration. I know that you don't understand right now. Don't worry, you are going to understand in 5 minutes. This is the problem a little bit closer. When you go up in the energy levels, the levels are going to be closer and closer and closer. Do you see that they are closer and closer? And they are going to have sublevels. Those sublevels are going to be filling out before. So for example, in the first one, I'm going to fill out the 1s, then I'm going to fill out the 2s, then I'm going to fill out the 2p, then I'm going to fill out the 3s, the 3p, and the 3d. But before the 3d, I need to fill out the 4s. Why? Because the 4s is before that. And of course, if we need to follow these rules, it's going to be like, what do I have to do? How do I do this? As I told you, luckily we have the periodic table, and as I told you always, the periodic table is a cheat sheet. So stay with me 2 more minutes. You are going to understand this mess. Now, if we look at the periodic table, we saw that the first layer is the first level. The second layer is the second level. The third layer is the third level, and we call that periods. But look at the letters here. S, 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 okay? So this is going to be the 1S, and these are the sublevels. The sublevel S is this yellow area here. The sublevel P is this area here. So in the first layer, we have only 1S, 1S. In the second layer, we have the 2S here, 2S, and also we have this one, the 2P. In the third layer, we have the 3S and the 3P. So I have 3S, 3P, and then I am going to have this one, which is the 3D. But you can see that these numbers are not the same. Do you see that this is 4 and this is 3D? That is because that overlapping that we saw in the layer before. Because when we talk about the layers, we said that the first layer is 1S, the second layer has 2S and 2P. Then the third layer has 3S, 3P, and 3D, but the 4S was here. And you can see that I'm going to fill out the 4S before filling the 3D. So what we are going to do is to follow this periodic table in order to fill out the electronic configuration. So let's say that I have now the sodium to fill out. What I'm going to do, the sodium has the atomic number 11. So how do am I going to do? Let me erase this so you don't get confused. And I'm going to fill out this together with you, following this, and you're going to see that there is no problem. So what I'm going to do, I'm going to put 11 electrons because I have 11 protons there. So 11 protons, I need to fill out 11 electrons. So I'm going to begin from top to bottom and from left to right, the same as reading a book. So I'm going to begin in the first one. What is this? This one is the 1S. 1S. How many boxes do I have here? 1 and 2. So I'm going to put 2. As this is the number of electrons that are in, or the number of columns that I have. Then what do I have? In here I don't have any more because the helium is supposed to be here. Now, because of the properties, we put it in with the noble gases. But do you see that it's in yellow? That is because it's supposed to be here. What happens here? After 1s2, I put already 2 electrons. I go to the second level. I put 2s because I need to fill out this. 2s. How many electrons? 1 and 2. 2 electrons. And then I have to fill out this one. I'm going to use another color for this one because if not, you're not going to see it because it's in red. I need to fill out this one. Why do I have to fill out this? Because sodium is located here. So I'm going to fill out every single level and sublevel that I had before. So 2s with 2 electrons and 2p with 1, 2, 3, 4, 5, and 6 electrons. Yes? And then in the last layer here, I have the 3s because it's 3s, this one, but I don't have 2 electrons. I have only 1. How do I know? Because the sodium is located here. So I'm going to put 3s1. Now look, what do I have here? In the first layer, I have 2 electrons. In the second layer, I have 2 plus 6, 8 electrons. And in the layer 3, I have 1 electron. How many do I have in total? 1 plus 8 plus 2 is equals to 11 electrons. Okay, we are going to combine all these things and we are going to do many exercises. You're going to see after you do the third exercise, it's going to be super, super simple to do. Okay, so what we are going to do is the electronic configuration of these elements that I have here. And I have magnesium, calcium, nitrogen, chlorine, and bromine. So the first thing that I'm going to put here is locate the elements. Magnesium is here, Mg. Calcium is here, Ca. Nitrogen is, I'm going to change the color. Nitrogen is, I think is here, nitrogen. Chlorine is here, and bromine is here. Okay, so I'm going to do these electronic configurations for you, and then we are going to do some exercises. And actually, you are going to kind of like this thing, I think, I hope. Okay, so what are you going to do? First, fill out the first level, then the second level, then the third level, until we get to the element. Okay, so in the magnesium, we need to put 12 electrons. How do I know that? Because the magnesium has 12 protons. We said number of protons the same as number of electrons. So number of protons equals to the number of electrons, so they are 12 electrons. So I'm going to begin. 1s2. Then I finish with this one. I go to this one, 2s2. After this one, I'm going to go to this one, and it's completed because the magnesium is here, 2p6. And then I'm going to put 3s2. Why 3s2? Because the magnesium is in the second column, 3s2. Now, which is the information that I need to take up from this? From this, I need to calculate the period and the group number. The period is going to be given by this number here. So this number here is period 3. And if you see, the magnesium is located in period 3. It's 1, 2, and 3. Okay, how many electrons has in the last level? The electrons in the last level, let me show you the electrons in the last level are this one here, 2. So that means that the group is going to be, the group is going to be group 2. Make sense? Yes, group 2 is where magnesium is located, and period 3 is where magnesium is located. So from the electronic configuration, I can see which is the group and the period number by looking at the last level of electrons. I'm going to do the same with calcium. Calcium is here. So I need to fill out up to 20. So I'm going to begin again. 1s2. And I hope that you stop the video, try to do it yourself, and then compare the answers with mine. 1s2. Then I finish with this one. I go to the second level. 2s2. Then I have to go all the way here on this side. 2p6. Then 3s2. Then I go all the way here, 3p6. And then the last one is going to be 4s2. So which are the which is the biggest number that I have? This is, I have 2 electrons in the first level. In the second level, I have 8. In the third level, I have 8. And in the fourth level, I have 2. So this is the last layer that I the last layer that I filled out. That means that the 4 is giving me the period number, period 4. Does it make sense? Yes, the calcium is in the period 4. And what about the amount of electrons in the last level? 2. So the group is 2, and we can see that the element is in the same group of magnesium. Magnesium and calcium ends in S2 because they belong in the same group. Okay, I'm going to erase all these so you don't get confused with the next ones. I hope that you can so far follow me, and I'm going to do the nitrogen now. The nitrogen is located here. We said nitrogen. So be careful with this one. This is a very common mistake. I'm going to do the electronic configuration of nitrogen, 7 electrons alone. So it's going to be 1s2. The first layer is completed. I go to the second layer, 2s2, and then I go to the p zone, which is here, this one here in this zone, and I have 1, 2, and 3. The nitrogen is number 3 in the p zone, so it's going to be 2p and 3 electrons. Now look at the group number and the period number. I have this is the highest level. So this is period 2, and it makes sense because the nitrogen is in the second period, is here, okay? And the group is 2 plus 3, which is 5. And if you look at the number that appears here in Roman numerals, it's number 5, group 5. Okay, now we are going to do the chlorine. Chlorine is here. Okay, so chlorine is 17. I'm going to do my 1s2, then 2s2, 2p6, because this one and this ones are completed, then 3s2, and then in here I don't have p6. I have 1, 2, 3, 4, and 5, so it's going to be 3p5. Yes, so now the last layer and the highest number is the 3. Okay, so this one is going to be period 3, and the group is going to be 2 plus 5 is equals to 7. That is the amount of electrons that they have in the last level. 2 in S and 3 in P. So we have 2 electrons here, and in here we are going to have 5 electrons. Okay, now the last one that I'm going to do is the bromine, and I'm going to continue with this. Now look at this. Do you see that this number, I'm sorry, is smaller than this one? Because this one is n minus 1. This is n is the principal number, the period number. So if this is 4, this is 3. If this is 5, this is 4. If this is 6, this is 5. Do you see that is always one less? And that is because that overlapping that we were looking at. So if we follow the numbers as they appear in here in the periodic table, we are not going to have any problem. Let's do it. So bromine is 35. So I'm going to begin doing the first layer. Okay, 1s2, the same as always. Then I'm going to do this one, 2s2. Then here, 2p6. And bromine is here, just in case. So we need to complete everything up to that level, 2p6. Then we have to jump to 3s2, then 3p6, because this one is completed and this one is completed, and then 4s2. Be careful. Then we have 3d, and if you don't remember how many electrons I need to put, just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it's 3d 10, and then 1, 2, 3, 4, 5 electrons in 4p. 4p 5. Now look at this. This is the last level. Yes, the highest level. So that means that bromine belongs in period equals to 4, because the highest number is going to give me the period number. Now how many electrons it has here? 2 plus 10 plus 5. So the group is going to be 17. When the D is completed, we don't count that, so we can say that is group 7. That's why some periodic tables have the number 17, including the periodic table that you have in our classroom. It says 17 or 7. 7 is for the smallest numbers. For these numbers, it should be 17. Okay, so Let me see if we have more exercises. Okay, do you remember that we said that sometimes the elements lose electrons or gain electrons? They want to lose electrons or gain electrons to get the configuration of a noble gas. So what is specifically what we are looking for in order to get the configuration of a noble gas? We are going to do the electronic configuration of neon. Neon has 10 electrons, so the electronic configuration is going to be 2 and 8, or if we do the sublevels, it's going to be 1s2, 2s2, 2p6. Okay, so it has 2 electrons in the first level, 8 electrons in the second level, 2 in s and 6 in p. The argon has 18, so it's going to be 2, 8, and 8, and that is going to be 1s2, 2s2, 2p6, 3s2, and 3p6. If you follow me with the periodic table, it's going to be much easier to see this. In the case of the krypton has 36 electrons. So it's going to have 2, then it's going to have 8, then 8 again, then it's going to have 18. 18 plus 2 is 20, plus 16 is 36 electrons. So neon has 10 electrons. Argon has 18 electrons. And krypton has 36 electrons. What is something that they share? Well, they share the electronic configuration of the last level, which looks exactly the same. S2, P6, 3s2, 3p6. Oh, I didn't do the electronic configuration of this one. I'm going to do the electronic configuration of krypton up here. It's going to be 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2, 3d10, and 4p6. So again, what do we have? 4s2, 4p6. Do you see that is s2p6, x2p6, s2p6? So every element that is in this table is not stable as they are. So they are going to lose or gain electrons in order to get this configuration. Of course, if they have more than 4 electrons, they are going to tend to get electrons. If they have less than 4, they are going to get to lose electrons. How many electrons? Well, that depends on how many they need to lose or gain. So let's analyze this example of oxygen. Oxygen has 8 electrons, is 2 and 6. So the electronic configuration is 1s2, 2s2, 2p4. That means that it's not stable. It wants to have the electronic configuration of neon, in this case, that is 2p6. So that's why it's going to gain 2 electrons and is going to form the -2 ion. So in that case, we can predict if the element is going to lose or gain electrons. In the particular case of sodium, it has the atomic number is 11. So it's going to have 2, 8, and 1. So the electronic configuration is going to be 1s2, 2s2, 2p6, 3s1. This extra electron is bothering the sodium. If it loses just that electron, it's going to have, again, the electronic configuration of neon. So it's going to lose 1 electron. And if it had 11 protons, it had 11 electrons, but it lost 1, so it's going to have 10 electrons now. And the charge is going to be +1. Why is that? 11 protons minus 10 electrons is going to give me the +1 charge. Okay? We are going to do the other one. You can pause the video and then you can try it yourself and try to see if you understand this. That is the best way of doing this. I'm going to do every single example so you have the information in the video, but that doesn't mean that you need to know it yourself. So in the sulfur atom has 16 protons, so it's going to be 2, 8, and 6. 2 plus 8 is 10, plus 6 is 16. It's going to be 1s2, 2s2, 2p6, 3 3s2, 3p4. Okay, so it's 2 plus 2 is 4, plus 6 is 10, and 6 more is 16. Again, same thing that happened here. You see that this one is 2p4, this one is 3p4, but the situation is the same. They want to have p6, so we are going to gain 2 electrons, and since it has 2 electrons extra, it's going to be -2. Instead of 16, it's going to have 18 electrons. Now, potassium is 19. Is 19, so it's going to be 2, 8, 8, and 1. Where do I get this? From the periodic table. And I'm going to do the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, again, same as before. We have 3s1 here, lose 1 electron, become 1 positive. 4s1, lose 1 electron, and it's going to become, instead of 19, it's going to have 18 electrons, so it's going to become +1. Okay, I did complete the atomic number for the elements that were missing, the amount of electrons in each level that you can confirm in the periodic table, and also the electronic configuration. We are going to review this just in case. This is 13 electrons, so we have 2 plus 2 is 4. Let me put a highlighter so you can see it. Is 2 here, plus 2 is 4, 10, and 7 is going to be 17. This one is the atomic number is 38, so it's going to have 2 plus 2 is 4, 10, 12, 18, 20, 30, 36, 38. And this one is 2, 4, 10, 12, 18, and 2, 20. These are the 20 that we have here. This is 2, 4, and 5 is 9, which is 9 that we have here. This is 35, so is 2, 4, 10, 12, 18, 20, 30, and 5, 35. And this one is only 7, so it's 2, 4, and I made a mistake here. It's not P5, it's P3. I knew that I had to review some of them. So this one is going to be, sorry, P3. Okay, now let's analyze what happens here. I'm going to take this one, and I'm going to see this one is 3s1. Okay, this one is 4s1, and both are going to form the +1 ion. Why? Because they are going to lose that electron in the last level. Sodium and potassium are in group 1 in the periodic table, so if you look at the periodic table, you can predict that if they are in group 1, they are going to lose 1 electron. In the case of the oxygen and the sulfur, the oxygen is 2p4 and this one is 3p4. So in this case, both are going to gain 2 electrons to form -2. In the same way, we can resolve the other ones. If you look at the electronic configuration of the aluminum has 3 electrons, so it's going to lose 3, and it's going to be plus 3 because it loses 3. So which is going to be the electronic configuration or the amount of electrons that they have? It had 13 at the beginning. 13 were the protons, so they had 13 electrons. If we take out these electrons from here, it's going to end up with 10 electrons. And then you have 17. So it's 3p5 is going to gain 1 electron. So instead of 17, it's going to get 18, and the charge is going to be -1 because it's gaining 1 electron. In this one, it's going to lose 2 because it has 5s2, yes, and that is what it bothers to the strontium to get the configuration of a noble gas. So this one is going to be +2, and the amount of electrons are going to be 36. Now, in the case of the calcium, again, it's going to lose these 2 electrons to get the configuration of a noble gas. So again, lose 2. Instead of 20, it's going to be 18, and the charge is going to be +2. In this one is P5, and the electronic configuration of the noble gas, remember that is 3p6, so it's going to gain 1 electron. So instead of 9, it's going to be 10 electrons, and the charge is going to be -1. The bromine has P5, so it's going to gain 1 electron, and it's going to end up with 36 electrons, and it's going to be -1. And the last one is P3. It can lose these 5 electrons or gain only 3, so it's going to gain 3, and it's going to end up with 10 electrons, and the charge is going to be -3. Now look at these numbers here: 10, 10, 10, 10. Those are the electronic configuration of neon, yes? So those elements are going to lose or gain electrons to get the configuration of neon. In the case of the sulfur, 18, 18, 18, 18, those are going to get the configuration of argon. And then the ones that I have here, 36 and 36, are going to get the configuration of krypton that has 36. So you have to be able to see if they are going to lose or gain electrons by getting the configuration of a noble gas. I missed this number 10 here at the bottom, but it doesn't matter. This one has 10, the same as the other one. I'm sorry, I'm drinking some water. Okay, so why did we do all these electronic configurations? Because we can make some assumptions now that any element that is in group 1, let me write it. So if there is in group 1, they are going to have the electronic configuration that ends up in S1. That means that that is the electron that is going to be lost. They are going to form the +1 ion. Okay, and the examples are sodium plus, potassium plus, lithium plus. Okay, all of those are going to lose 1 electron and form the +1 ion. How do I know that they are going to have only 1 extra electron? Because the electronic configuration ends in whichever is the period number, S1. If they are in group 2, they are going to have the electronic configuration that ends in N, where N is the period, S2. So they are going to form the +2 ion, like calcium, that forms the 2+ ion, or strontium, Sr, that forms the 2+ ion, or barium, that forms the 2+ ion. And then in the group 3, they are going to end in NS2 and P1. They are going to form the positive 3 ion, like aluminum 3+, or gallium 3+. There are more, but I'm going to give you only those examples. Now, what happens in the group 4? Group 4, sometimes they lose, sometimes they gain. That depends on what they have in front. So if they lose, they're going to lose the 4 electrons. That is going to form the +4. Or if they gain the 4 electrons, they are going to form the -4. This is something that happens, for example, with a carbon. Okay, in the group 5, they are going to end up, the electronic configuration is going to be NS2 and P3. So they are going to form the -3 ion. For example, nitrogen 3 negative, that is called nitride, or phosphide, which is the 3 negative ion of the phosphorus. The negatives change the name. We are going to see that when we see nomenclature. So far, negative and nitrogen 3 negative or phosphorus 3 negative. In the group 6, what happens? We are going to have NS2 and it's not 3, it's N. Oops. 3 is not 3, is N. N and NP4. So they are going to have 6 electrons in the last level. They are going to form the -2 ion, that is oxygen -2 or sulfur -2, what we call oxide or sulfide. Group 7, and we are almost done. They are gonna have NS2, where N is the period what they belong to. NS2 and P5. Of course, they are going to get the -1 ion. And that is the case of the fluoride or the chloride. And the last one is group 8, which has the NS2 and P6, and they do not form ions.